let's think about straight lines. You're going to need to draw some sets of axes with me. They don't have to be huge because the things we're drawing are not very detailed. They're just straight lines. Let's start with a normal set of axes. And kind of the most basic lines you can have are actually the ones I've kind of already drawn on there. The axes themselves. Okay. So if you think about the axes, they themselves are straight lines. By the way, from now on, you kind of got a sense of this. When I say line, I do mean straight lines, right? I don't mean like, oh, this is a curvy line. In mathematics, when they say linear, they mean straight, okay? So, the x and y axes are themselves straight lines, and they each have an equation, right? So let's, for instance, think about the vertical axis here, the y-axis, right? Along this y-axis, y can take any value. But every single point on there, they all have the same x value. Do they not? Because they're all like stacked up on top of each other. And that same x value, of course, is 0. Right. So the equation of the y-axis is x equals 0. Now, by implication, therefore, if we have another line that's also vertical, but not on the same spot, let's draw another one there. Like, say, this. If it's parallel, it's doing the same kind of thing. Y can take any value, but x, they all share the same value. Just, it's a different value, okay? So if its intercept is A, we'd say that this vertical line is x equals A, okay? Following exactly the same logic, we've got our x-axis as well. X values can take anything, but all of the y values are the same. They're all 0. Right? We're awake, good, okay? Y equals 0, which means by implication, if you have any other horizontal line on the graph, like say up here, and if its intercept with the y-axis is, let's call it B, then of course this is going to be y equals B, and they are parallel. Okay? Worth noting that the horizontal lines, right, they both have gradients. They're gradients because they're not rising. Their gradients are 0. Okay, m equals 0. The vertical lines, because they are kind of rising, but they're not running anywhere, right? Yeah, it's kind of weird. You might think, oh, it's kind of like infinite, it's going straight up. But the thing is that we're dividing by, like, gradient is rise over run, isn't it? And they're not running anywhere. Even though I've drawn it, these lines have no thickness. Okay, so they literally have no run. So therefore, you can't divide by 0. Right? So these don't have a gradient. They are undefined. It's not infinite, the gradient is undefined. Okay. Which is a critically important idea. Excellent. Now, these are the most simple kinds of lines. Let's draw a new set of axes here. When you start looking at all the rest of the lines, it's just those, and they're just tilted at different angles and in different positions. That's all they are. Okay? So we would say after you horizontal and vertical lines, you would say the general kind of line, the general form for writing a line, we say is, just to make sure there's a convention so we can all communicate in a consistent way, is AX plus BY plus C. Okay, so where is this on our graph? If I were to draw a line like, say, this, let's imagine that's our general line. Okay, it's got two important features we need to know, namely X-intercept and Y-intercept, right? How are we going to work out the X-intercept? What do we do to the equation to find the X-intercept? You let Y equal 0, because that's the equation, right? We're finding a point of intersection, right? So when Y equals 0, you're getting AX plus C equals 0. So when you rearrange that a little bit, you're going to get, over here, minus C on A, right? You've got to get that on its own, so you take the C over the other side, which makes it minus C, and then you don't want AX, you just want X, so you divide it by A. In exactly the same way, what Y-intercept are you going to get? Yeah, you pull the same trick, right? You let X equal 0 this time, then you've got BY plus C, you take the C over again, same thing. Okay, now that looks a little weird, doesn't it? Right? Because That one's okay because it's negative, it's over there. This says it's negative, but I've drawn it above the x-axis. Why would that be? What does that imply?
Negative.
It means that either B or C, one of them, must be negative, right? And you can put in some values and test that. That's fairly standard. So from general form and horizontal and vertical lines, right? You then get 4 other ways of writing the same kinds of lines. They're just forms. And it just depends on what features you want, right? 4 different ways. We'll do them all together, but can you think of what the 4 ways are so that we can go through them? What's the first way that you can think of that will name a feature for you? Most obvious one. Okay, there's going to be point gradient form. That's usually the first one people come up with. Give me another one.
Gradient intercept.
Oh, okay, all right, I heard, I'll do this, hold on. Yeah, I've got gradient intercepts. Gradient intercept form. So, sorry, let me put it back a little bit. This equation of the line, right, the form that it's in, you can read off what point it passes through and what gradient it has. Here, you can read off what gradient it has and where it passes what? What intercept is that referring to? The y-axis. I heard 2 points. 2 points. 2-point form. That's 3 forms, right? There's one more. There's one more that tells you a geometric feature or geometric features. A bit unusual. It's not. I've got general form. I've already got it there. There's another one. It's very uncommon, I'll admit. It's very similar to this one. Rather than 2-point form, which is just 2 points anywhere in space, you can have. Did I hear someone say 2 gradient? 2 gradient form. It's that's a fancy line. 2 intercept form, right? Just like this and this, it's like an intercept with the axis versus a point anywhere in space. This is an intercept with the axis, actually it's both of them, versus 2 points in space. Okay? So, what we'll do is, okay, set of axes now, we'll do a set of axes for each one. We will do, let's do gradient intercept, I think, gradient intercept. Okay, now you know what the form is. It's been drilled into you quite thoroughly by now, and you guys are good at it. But how do you arrive at that form? Okay, we have gradient and we have intercept defined. You can see it on the board. What's the standard name for the y-intercept? Usually, not always, but usually. It's usually B. Like that's the most common one. As you can see, it's not always B, but we're trying to keep it consistent usually. Okay. So if I have some point B, let's put it there. Okay. In fact, I'm pretty much going to draw it the same as this. Okay. And I have, excuse me, a defined gradient. Okay. How are we going to get out of this that there is, well, you guys know what the answer is, but how do we get there? Here's what I'm going to do, right? Whatever equation of a line I come up with, it should satisfy every single point on this line. Do you agree? Every single point on this line. So for example, a point on this line, I'm going to call it x, comma, y. Right? Not x1, y1 as if it was an actual value. I mean x and y as in all the x values and all their corresponding y values that are on this line. So these guys are variables. Okay? Now remember, I've got my intercept on there already. The other thing I know is a gradient. So how am I going to connect gradient to this diagram? Where does gradient belong on this diagram? You can draw a triangle, can't you? Draw this triangle. Okay. So we've got a rise here. This is rise, and we have run here. Okay. So how do we work out each one? Let's do rise first, shall we? It's this vertical distance, right? It's going to be the top minus the bottom, right? Top minus bottom. The top value is y, whatever that happens to be, right? And the bottom value is b, right? So in this case, rise is y minus b. You happy with that? Yeah. In the same way, having a look at run, okay, I'm going to take this further value and subtract this original value. Now, this is b, but its actual coordinates are, what are the coordinates at this point?
0,
it's run on the x-axis, so it should be 0, b. Does that make sense? So here, it'll be this value minus that value. It's going to be x. You okay with that? Okay, so there's rise over run, okay? But I'm defining that as some gradient, some number that you want to choose, okay? That's the whole point, that's the feature I read up. So now, I don't have to do very much to this, do I? To get my familiar form, I'll multiply through by x, sorry, there's a b there, right? And then I just make y the subject, et voila. Okay, you happy with that?